Hello, good afternoon. I would like to share with you our experience, specifically about the update of Classiq. First of all, this keynote presentation was actually to be delivered by our CEO, Neil Minarabi, but there was a fundraising, and because of this, I had to step in because he had to stay in his home country. Now, first of all, let me introduce you myself very briefly. So, in November 2023, I joined the company, and I was the first company in Japan. So this is the first time for my personal life to be the first person in the Japanese company, Japanese subsidiary. And then so before I joined in Classiq, I had nothing to do with quantum, but I had work on the business development in other companies. And I believe that still, even if I never had experience of working in quantum technologies industry, I believe that my contribution in the areas of business development could be helpful. So here's our latest update. Maybe some of you might know Classiq. As our latest update, we completed round C, $110 million or 16.5 billion yen. Probably this is the largest investment in quantum software. It's about 26 billion yen, including rounds A, B, and C. We do have press release in Japanese and English about the investment rounds of funding. So I hope that you would access this information if you're interested. Now, I would like to introduce to you about our company and people, and then I would like to talk about the reason why Classiq is important, and also I would like to touch upon community and use cases, and also I would like to talk about the product roadmap, and then as closing, because we have received a fund, we like to do various things in Japan. So as country manager, I would like to share with you some of the things that we're planning to do in this market. Now, first, Classiq were established in 2020 in May, and a year later, Japanese office was established. Globally, we have 70 people, and I think there's one thing which is unique, which is 11 out of 70 people come from Talpiot program. This Talpiot program, you might know. Well, these days, Israel is having a bit of difficulty, but they have recruit for the forces, and every year, and then so recruit like 20,000 people every year, and then 30 of them are selected as very excellent people, and then under the construction system, and so these 30 people are super talented people, and actually 11 of our company employees have come from Talpiot program. And we do provide the quantum platforms. We have raised a fund of $173 million. We have offices in Tel Aviv, Tokyo, and of course also in the Netherlands. And also our office in Tokyo is located in New Marubil building, just in front of Tokyo Station. So I hope that you will visit us if you're interested. Now, these are our people. Classiq in Tokyo. I'm sorry, this slide has lots of text, but just putting me on the left side, I have Genki Okano, we have Rei Sato, and also we have Mio Endo, and they're all having very diverse background, luckily, and we're having great time, and we are working very hard. And here's our mission. As you see in the center of the slide, we provide hardware, quantum ecosystem, and software, and we are really focusing on the software domain of the quantum industry. We have many people in this room coming from the hardware, but we are from software, 100%. That's the unique point about our company. And also Classiq, this is actually a comment made by our CEO. Classiq wants to become a Microsoft in quantum computing. So he's a young CEO and he has a very aspiring goal. And we are really rushing forward to achieve this goal. So we have an exhibition booth, so I would like to share with you the details about our services at our booth, but let me share with you the high-level information. As you see at the top, we provide the end-to-end SaaS platform for the quantum application development. You see on the right side, we have design, debug, and also optimization and execution. So through these 4 steps, you'll be able to develop a quantum application on our platform. So we have the model, you have the model, synthesis engine, you have the debugger, and also OS. We have all those things. One of our assets is really our patents. As you see on the left side, we have the like 70, up to 70 patents for modeling, compiling, debug, and OS. So these are our assets. And thanks to the funds we received, we are capable of developing all those great things. And I do believe that these are the value that investors see in us. So now I would like to talk about why Classiq. I mean, already in the market, there are many different types of platforms and also quantum languages. Why are we developing Classiq? On the higher level, here are the challenges that we face in programming for quantum. Of course, there are many other hurdles, but I think these are the 3 major challenges people face. First is that we have to use a low-level language. This is hard. When we meet people in our booth, I hear many times that customers complain the hard effort is required for programming a low language. And also, second is the limitation of the manual work. When we are handling just dozens of qubits, it's okay to do manual work. But if it comes like thousands or tens of thousands of bits, then you can't do it manually. So one line of this is like 100 or so. So you see how many of the lines of such will be required to count like tens of thousands of bits. So there's no way to do this manually. Now, third is accommodation for different types of hardwares. There are different types of hardware like superconducting, quantum computing, computers, or many other types. And it is not possible to accommodate all those different topologies and architectures. And today, if you are programming with low-level languages and make adjustment to different types of hardwares, it means a huge amount of work. So we wanted to solve this problem for our customers. Well, first of all, this is one of the solutions that we provide. First is to provide high-level quantum language called QMOD. IEEE is where we plan to propose. This is the first thing we introduced. For your information, on the right side, you see the code or program for quantum circuit written in the conventional way. But the same thing can be expressed with our QMOD language. Secondly, we have the synthesis engine. This is carefully protected with our IP. We try to provide 2 values for the problems of the manual work. First is automation, and second is optimization of the circuit size. With these 2 combined, a great advantage can be enjoyed by our customers. Thirdly is the hardware agnostics. This means the multimodality accommodations. Classiq, quantum, hybrid, there are different types of computing powers available and being sought out. So for Classiq, as you see on the left side, we have different types of the QPUs. Different types of models do exist. And so we support them, and we also support the Hewlett-Packard HP. We provide the support for the NVIDIA, IBM, Amazon, and they all have different types of quantum cloud. so that the customers do not have to choose specific hardware. So in summary, number one, manual versus automation. At the top, you see the conventional technology. In most cases, I think the developers are working on this in this workflow. You develop the model, you design the circuit, you optimize the circuit, and then you consider and optimize the circuit considering hardware, and then transpile. For the first 4 buckets, you have to do manual work. Maybe the transpile is automated, but the rest 4 buckets are manual. Now, in Classiq, model development is manual. This is something people have to do still, but all the 4 stages can be done automatically. So from the engineer's point of view, they can really focus 100% of their time on the structuring or the designing of the model. So we believe this is a huge benefit to the engineers. And then we made this headline here. Quantum advantage does not arrive to everybody equally. It's great to have the quantum advantage. Quera, Google, IBM, all those people are working different things, and the quantum technology is advancing day in and day out. But as you see on the second point, the downsizing of the quantum circuit have importance in 2 aspects. First, if you could reduce the size of the circuit, you can reduce the cost for a very expensive quantum computer. This is a very serious problem for many people. The available quantum computer resource is limited, and it's very costly, I mean, in terms of the access cost. But if you use our compression or circuit downsizing technology, as you see on the right side, this is a case of the effort by Mitsubishi Chemicals and Deloitte, and they could actually reduce the size of circuit by 97%, meaning with only 10% of the cost, they could possibly use the resource of the same level. So it's not, I mean, in reality, it's not that simple, but although our solution is not 0 yen, but it easily weighs out the cost of using our technology.
And the second point is that in order to realize quantum advantage, there's a formula. So you will need to have resources that's necessary for computation, but this must be less or than the hardware performance. So in other words, hardware performance needs to be higher. So by compressing, we will be able to reduce the resources and meet this criteria. And at the bottom, you can see the IBM's hardware development roadmap. So in 2027, they're aiming for number of gates 10,000. And perhaps we don't have to wait until 2029. Maybe in 2027, we may be able to obtain the first mover's advantage. So changing the subject, I want to talk about the community and the use cases. In 2020, we were established, and basically our growth has been community-driven, and we have many users, and one of the users is academia. So we have global users, researchers using us, and so we work with more than 500 plus universities, 2,500 plus organizations, and 5,500 plus Slack members. So for us, in terms of growth, we want to continue to pursue this path. With regards to the use case, maybe you have already seen this before, but I have tried to summarize it here. So we have partnership with HPE, collaboration with BMW, with Wolfram, many, Microsoft as well. And we'll be highlighting just a few of them to give you some specific examples of the use case. So first use case is CFD. So this is the computational fluid dynamic simulation in the aviation industry. So we're using NVIDIA's simulator with 1,000. We run this at 1,000 gates. And of course, we need to improve the hardwares and also maybe take into consideration of the performance of the hardware, but we have more than 1,000, even greater than that. So once the hardware is ready, we will be able to move on to the next step. The second use case is this is on the quantum Monte Carlo method. In March this year, we worked with Mizuhomo, Daiichi Financial Technology, and Sumitomo Corporation. This is quantum Monte Carlo method, so we will compress the circuit, and we have found that we have been able to achieve up to 95% of the circuit compression for the quantum. And by compressing the circuit, we can reduce resources. And since the hardware, even though they say they claim to be FTQC, they're not able to do a large amount of quantum bits. So they basically need to minimize the resource requirement. So I think by compressing the circuit, we'd be able to accommodate the constraints of the hardware today. And this is more new, more technical. We collaborate with BMW on optimization of automotive cooling system. This is heat conduction equation. What we need to highlight here is that we're using 5 use cases of quantum algorithms and the results. And we do have papers in the archive. So if you're interested, I hope you will get a chance to look at it. Also, as you can see in the photo, Nati, who's responsible for technical side of it, he's here in Japan. So if you wish to hear more details, please visit us at the booth. This is collaboration with CERN. Many of you know what CERN is, but this is integration and collaboration with Wolfram in CERN, OQI. So there's a project of developing a smart grid using quantum, and we want to do this in Japan as much as we can. So I hope that you will look forward to this use of quantum optimization for smart grid development. So next section is on product roadmap. You have a lot of words here on the future roadmap, time constraints. I will not go into the details, but we have the focus of usability, scale, and ecosystem. Our development is based on these 3 perspectives, especially because we have the funds of 110 million funneled into our projects. So these basically scale and usability with AI is a must. If I was to highlight some of the words in here, AI, people talk about AI but all the time, but bundling with AI, how can we realize synergy with AI so that improve our platform? We have different studies and considerations internally, and we do have a pilot project with a beta version that we're running right now, so the development is underway. And the other keyword is scalability. So by utilizing CPU, GPU, and QPU, we will be able to deal with complex hybrid use cases. We do support it already, but we would even be able to do this more smoothly and also at a larger scale. And in the ecosystem, we have Classiq Studio. This is primary development. We want to continue to expand. So in closing, just 2 more slides. What do we do as a Japan office? This is more of a sales talk, but we want to expand our business in APAC. We want to make Japan as an APAC hub. We will be expand sales channels in Korea, Taiwan, Singapore, Australia. We would also recruit and strengthen. We also have a partnership strategy. We would like to collaborate with local hardware vendors, not coming from overseas to Japan, but I'm wondering if we can go from Japan to overseas. And fourthly, collaborating with academia and government organizations. Again, talent recruitment. This is very common these days, but we're looking to hire many new staff to expand our office functions. If any of you are interested, we're here at the booth, so please approach us. In particular, we're looking for quantum engineer. We're looking for student interns. We need people for business development. I'm the only person responsible for sales. I want people who will be willing to work with me. Recruiting right now, so join us if you're interested. So that is all from Classiq. Thank you. Our time is a little tight, but there is one question. If you could answer maybe just one question. Aside from the resource compression, what does it have any function for error mitigation or error correction? So we have tested error correction in service code, but we think it's a little bit early to launch it in the market. But we will are very agile. We will, if it's necessary, we will launch it in the market. Thank you. Then please give him another big round of applause. Thank you.